We think of life as confined to a single planet. But the nature of life is to spread. To seek out new horizons. To take root on foreign shores in search of new soils. To make its mark on the cosmos.
If you were to travel back in time 4.4 billion years ago, you might not have picked Earth as the future cradle of life. But Mars. Smaller and quicker to cool, Mars formed a solid crust and flowing water long before the Earth, giving it a 100 million year head start to spark life. Clues from Martian meteorites and rovers tell the story of a once vibrant world, with rivers winding across ancient valleys, lakes pooling in craters, and a vast open ocean spanning the northern hemisphere. In Jezero Crater, an ancient river delta, NASA's Perseverance rover found a curious mudstone rock named Shayava Falls. Formed when liquid water covered the planet billions of years ago. It contains strange pale leopard spots, each rich in minerals and organic molecules that on Earth often point to microbial activity. So far, researchers have no natural explanation for these patterns, meaning that these spots could be the fossils of ancient Martian microbes, and our first true glimpse at alien life. But if there really was life here long ago, it would have been under attack. Pummeled by a 300 million year asteroid storm. On the surface, these impacts would have been apocalyptic for life. But underground, they may have been a gift. Residual heat from large impacts may have created thousands of underground mineral-rich water systems that stayed heated for millions of years. Ideal incubators for life, protected from the chaos on the surface. But the barrage of impacts had another effect. Rocks blasted into space by the impacts spread throughout the solar system, with billions of tons of Martian material making contact with Earth. "13,000 years ago, one of these rocks struck the Allen Hills in Antarctica. It was found to have originated in a deep Martian canyon at a time when Mars still had flowing water. And deep inside, we found these. Strange structures that look like fossilized bacteria. It now appears they are just natural mineral formations, but these structures stirred a deep question. What if it wasn't just Martian rocks coming to Earth, but Martian life? What if our oldest ancestors came from Mars? Or further beyond. This is the theory of panspermia. And for it to work, life has to survive the gauntlet. A 3-stage journey from hell. First stage. Survive being launched into space several times faster than a speeding bullet. Inside a superheated fragment of rock with surface temperatures exceeding 1,000 degrees Celsius. Second stage. Endure the long journey through the frozen vacuum of space. Devoid of water, air, or nutrients for potentially millions of years. All while being bombarded by ultraviolet radiation that can shred DNA to pieces. Final stage. Withstand the fiery re-entry to a new world as your frozen lifeboat becomes a fireball.
Life finds a way.
Spores of the bacterium Bacillus subtilis have been recovered alive just millimeters inside a rock as its outer surface was superheated to over 400 degrees Celsius. Tardigrades, one of the smallest and hardiest animals known, have been witnessed surviving the freezing vacuum of space for at least 10 days without protection. They do this with a unique protein called D-sup, which forms a protective cloud around their DNA. But when it comes to battling radiation, the undisputed king is the bacterium Deinococcus radiodurans. It can withstand radiation levels 1,000 times higher than a dose fatal to humans. Its superpower is its ability to reassemble its own shattered DNA, rebuilding its entire genome in a matter of hours. microbial remains contain fragments of DNA that carry valuable information. These fragments could have spilled out into Earth's primordial soup, providing ready-made materials to jumpstart life. This is the theory of necropanspermia.
Like manna from heaven, the essential molecules of life could have rained down on our planet from some ancient branch of life. If true, Earth life could be written with borrowed words from a story that began far from our shores, delivered here by microbial martyrs.
But perhaps it was the other way around. Perhaps Earth was the cradle for life and a launch pad for its journey to other worlds. Tens of millions of rock fragments from Earth have made it to Mars. But due to its closer orbit, Venus may have received far more, potentially 100 times more over the eons. Together, these three planets formed a bustling meteoric trade network, sharing billions of fragments over billions of years. Some rocks travel as far as Jupiter and its moons, potentially seeding their underground oceans. Even Saturn is thought to have received possibly millions of Earth fragments, some splashing down into the liquid methane lakes of Titan. Seen in this way, the solar system could be a constellation of life, intermixing its biochemistry through an interplanetary asteroid highway. This might only be scratching the surface. In fact, life could be connected not just between planets, but between entire star systems. The average distance between neighboring stars in our cosmic neighborhood is about 4 light years, around 40 trillion kilometers. This journey would take millions of times longer, making survival even less probable. But not impossible. Studies show that microbes shielded inside 3 feet of rock could survive the cosmic radiation of deep space for tens of millions of years. Comets could make the perfect interstellar arcs, as their thick mantles of water ice form a natural radiation shield for any microbial passengers. best way to close the gap is to pack the stars closer together. Most stars in the universe are born within dense clusters, packed in tight with other suns. In these crowded cosmic neighborhoods, the distance between stars isn't measured in light years, but in light months or light weeks. Our own sun was no exception. Born inside a crowded stellar nursery with neighbors far closer than they are today. During this period, lasting up to 90 million years, our solar system and its nearest neighbor could have swapped up to 30 quadrillion solid objects. As many as 200 billion rocks from the young life-bearing Earth could have reached alien star systems. If we ever touch down on nearby alien worlds, we might just find that they are part of our family tree. And some star systems could be even more interconnected. Globular clusters, the dense swarms of stars that orbit our galaxy, contain thousands or millions of suns packed into a tight ball. For any planets inside these clusters, the night sky would be permanently ablaze with thousands of nearby stars. Some shining as brightly as full moons. These stellar densities, an asteroid carrying microbial life wouldn't need millions of years to reach the next star system, but perhaps only thousands. Across our galaxy, trillions and trillions of rogue planets wander the darkness alone, cast out of their home system. Their surfaces frozen to near absolute zero. But deep inside, some could retain a molten core, which could supply heat to a subsurface ocean. A perfect sanctuary for an interstellar journey. Down here, hidden biospheres could sail safely through the void for millions or even billions of years, using the planet itself as a starship. A lucky few could even make the epic journey to an entirely new galaxy. But potentially making panspermia an intergalactic phenomenon. But what if life didn't need to ride a planet or rock at all? By constructing a living shell to keep in heat and block radiation, communities of cells could weave their own wandering habitats. Self-sustaining bubbles of life that float through space like miniature living planets. Inside, they'd hold liquid water, recycle nutrients, and use distant sunlight for energy. All without ever landing on a planet. By optimizing their size to a few meters wide, they'd be strong enough to hold pressure, yet light enough to drift through space like cosmic plankton. Imagine a creature so large that it rivals the size of entire planets. It glides gracefully through the void, guided by an internal organ that senses the faint gravitational pull of distant suns. Despite its completely alien nature, this titanic creature voyages the darkness for a familiar reason: to raise its young, using entire worlds as incubators. cosmic gardeners, advanced civilizations could be casting seeds of life across the universe, possibly as backup copies of their species. They could treat the galaxy like a vast garden bed, spreading seeds and watching how they take root on different worlds. We could even discover that our own tree of life is just a branch of another civilization's ancient grand experiment.